Okay, so these are our periodic trends notes. So if you don't have your Cornell Notes template open already, then go ahead and go to our classwork page. Here, scroll down to Unit 6, and you're going to open up Periodic Trends Notes, and you should have a copy there of the Cornell Notes template to take your notes on. All right, so let's go ahead and get started. All right, periodic table trends. So we've talked a little bit about periodic table trends, but we're going to talk about a little bit more here today. And we're going to see what else can we learn about an element based on where it is on the periodic table. Okay, so the essential question today for these notes are, what are the trends on the periodic table and how can they be used? Okay, a couple definitions I kind of want to get out of the way with you so you kind of understand what I'm talking about as I go through these notes. Is the first was the atomic radius. So remember, we talked about a radius of a circle in math. It goes from the center to the outside outline of a circle. Kind of the same idea. Remember, we talked about Bohr models and how to tell how many energy levels or rings was on each atom, and that those electrons are the ones that go around in those rings. Well, the radius is the distance from the center of one atom to its outermost electron. So think of that big circle, it's on the outside. That is the atomic radius of an atom. Then we also have ionization. What is that? That is the energy required to remove an electron from a gaseous ion or an atom. So just really know that that is the energy required to remove an electron. It's going to become an ion. And that definition is down here. And that's how I remember that it's an ion. So an ion is a positive or negatively charged atom or molecule. Remember when we talked about last semester, we talked about how all of the things we were talking about on the periodic table were what we call neutral. They didn't have a positive or negative because they had the same number of protons and the same number of electrons. So now we're going to find out, well, what happens if we remove or add an electron? So if you remove or add an electron, so if it's not neutral, if it's positive or negative, that is called an ion. So ionization is actually the energy required to remove an electron. So it makes that atom an ion. So that's why we call it ionization, or to remove an electron. Now, electronegativity is a measure of the tendency of an atom to attract a bonding pair of electrons. So that's where we would bring an electron in. Okay, and so it adds an electron. So it's electronegativity. Okay, it adds an electron, which means it's going to become more negative. Ionization means going to give up an electron. It's going to send it away. Okay, and so then it become more positive. And of course, we'll talk about this a little more because it's like probably rattling around in your brain going, oh my gosh, Ms. V, I don't totally get it. Just remember, ionization needs to remove an electron. Electronegativity is to attract an electron. Okay. All right. So another definition I want you to understand, because I'm going to use it, it's going to be in our PAGO, is called Coulombic attraction. And it sounds super complicated. It's not. It is basically a force of attraction between positive and negative charges. Just like a magnet, positive pole, negative pole, they attract each other. That's what it is. Okay, and the same thing, as I told you, happens in atoms. You have the positive protons, the negative electrons, and they are attracted to each other. And they're not quite sure why the electrons don't come straight and bang into the protons, but they don't. They kind of orbit, but they do have that attraction, positive and negative. Okay. Like I said, example, magnets. Does the attraction, and think about it as we go through some of these trends, I'm going to use magnets as kind of an example. Does the attraction of magnets get stronger or weaker as you move them closer together? Do the magnets kind of hit each other when you get closer, or do they kind of repel each other if you're doing positive and negative? Okay. All right, so atomic radius is the first trend we're going to talk about. And so the atomic radius, remember, is from the center of the atom to the outermost electron. So what does it look like? Well, the atomic radius actually, as we go from left to right, you can see it increases as you go from right to left, but you can also say it decreases. So our atoms actually do get smaller as we go from left to right and increase as we go down. Why the heck does this happen? Well, remember I just talked about your Coulombic attraction, right? As we go across a period on the table, what happens is we're increasing the number of protons in the center. So we're increasing that positive, which means we're going to have a stronger force inside, okay? But we're not increasing, remember, it's to the outermost electron. We're not having those electrons move farther away. We're not adding energy levels or rings as we go across, because each period it increases as you go down. But we're not adding those. So what's happening is as you increase the protons, as those atomic numbers get bigger, it's pulling those electrons in closer to the protons, and so that's why we end up with a smaller radius. And as we go down, this is a little more easier to understand. We're going to add those energy levels, we're going to add those rings, which causes that radius to get bigger, okay? And so that's why atomic radius has that trend, okay? The second one we're going to talk about, and I have to make sure I didn't skip anything because it looks like there was a blank one. Nope, it must be electronegativity is my next one. Okay, so electronegativity, if you remember from our definitions, was the ability to pull an electron in. So what happens there? Well, as you go from left to right, it increases, and as you go down, it actually decreases, or as you go up, it increases, okay? So it increases as it goes to the right. Why does that happen? Well, once again, as you increase the protons in the center, okay, you're having more attraction of the electrons. And as you go across a period on the periodic table, what's happening is you're not having the rings increase. So the radius is not increasing, it's actually decreasing. And so it's exposing that really positive center really more. And so those centers are now able to go and grab electrons from other atoms more easily as you go from left to right. As we go down, remember our radius does increase, so there's more energy levels, there's more space before you get to the center protons, and so that's why it does decrease as you go down or increase as you go up, because now there's more space. So remember, like a magnet, right? As a magnet gets closer and closer, so as that negative part gets to the positive part of the magnet, that pull of those magnets is stronger. They want to be together. But as you move them farther apart, there's less there. So those nucleuses are farther apart, and so they can't, those protons are farther from electrons, so they can't pull them as easily because they're farther away. So if you think about a magnet, that's why it's not pulling those electrons as much, okay? The last one we're going to talk about is that ionization, and it has the same trend as your electronegativity. Okay, and remember, ionization is the ability to just get rid of an electron. Okay, it basically just says, oh, see you later. Okay, and so what happens is this ionization energy, that's how much energy it takes, okay, to pull an electron off. So if you think about it, it increases as we go across a period. Why does that happen? Well, again, our radius is decreasing, okay? So if our radius is decreasing, that the magnets are getting closer together, right? So there's more of a pull. Well, what happens when you get those magnets closer together with how much energy you have to put in to pull them apart? If they're really close, you got to really tug on them to get them apart, right? And so as the radius decreases, that attraction is higher. That Coulombic attraction is so high that it takes a lot of energy to pull that electron off away from the protons. And as we go down, it actually decreases. Why does it happen? Because again, just like magnets, if you have them farther apart, it's really easy to pull that magnet off and take it anywhere you want to go. Same with electrons. The more space is between the protons and electrons, the easier it is to pull it off, but the harder it is to bring one in. So just think of it that way, okay? Okay, ions and ionization energy. So this is kind of a just graph of what happens. Remember, I said that ionization increases as it goes from left to right. So if we look at the atomic numbers, so we have atomic number 1, this is hydrogen. And so it's on the far left of our periodic table. So it has kind of a lower ionization energy, which means it's doesn't take a lot of energy to pick off that electron, right? But if we go all the way to the right to helium, it jumps right up. So you'll notice all the ones that are on these little peaks here have the highest amount of energy to remove that electron are going to be our noble gases. But each one is a different element. So you've got hydrogen, and you just go across because this is our atomic numbers, right? 1, 2, 3, 4. So you go hydrogen, helium, and of course I'm going to have to remember how to get there. So you go hydrogen, helium, lithium, beryllium. And so this is just a graph of how these all jump around. So you got hydrogen, helium, then you have lithium. Now it's on our far left again, so it's pretty low. Okay, and then it goes up, beryllium. Sometimes it always doesn't follow the trend perfectly, but it kind of follows a trend where it goes straight up. Okay, you may see something on the test that looks like this, where you're going to have to identify what element it is. Remember, this is our atomic number, so you just follow the periodic table. We go atomic number 1, 2, 3, 4, 5, 6, 7, 8. Okay. All right, how about the relationships between our 3 trends? Well, because you know how we love relationships here in chemistry, you have electronegativity, which is the ability to attract an electron, and ionization energy, the energy required to remove an electron, are directly related. Okay, so they are the same. If electronegativity is high, ionization energy is also high. Okay, atomic radius is our odd guy out. So it is our indirect relationship, okay? So basically, atomic radius has an indirect relationship with ionization and electronegativity. So if electronegativity goes up, radius goes down. So those are the relationships between those 3 trends, okay? All right, so now what I want you to do is go back and process your notes. You're going to highlight any important notes. You're going to make connections to any of your notes in the left-hand column. You're writing questions you may have in the left-hand column. You're going to use your highlights, connections, and questions for your summary, and then write a 3 to 5 sentence summary. If you have any questions, please let me know.